This lecture is on the vascular tunic of the eye. So this now is the middle tunic, the middle layer. Then also, so this is the vascular tunic. Also known as the uvea. And as the name implies, it is made out of highly vascularized tissue. This means tissue with a lot of blood vessels in it. And the posterior 5/6 then of the vascular tunic is the choroid membrane, also known sometimes as the choroid coat. So what did I just say? I'm going to start drawing a picture now, and we will work on it as we go along. So again, you're going to be looking at an eye that has had a slice taken through it. So here we have the roughly spherical part. Here we have the part at the front that bulges out a little bit. I'm going to make that a little bit more subtle here. Like that. All right. Now, as you recall, we have the fibrous tunic on the outside. Here we are again, right? There's the fibrous tunic. Now, since the vascular tunic, as the name implies, has blood vessels in it, let us start drawing this using red. So now we are talking about, so as I said, the posterior 5/6. So here on the inside, we have the vascular tunic going forward like this. So here now we have the choroid coat here. Now you may notice that I didn't include it there, and that is because at the back of the eye, not the exact back, but a little bit down from the exact back, is where we have the optic nerve coming out. So here's the optic nerve, like so. This is what carries the sensory information about light from your eye to your brain. So there's the optic nerve. And the choroid coat then is incomplete in this area here. So I'm just writing this in. So I'm simply going to say right here, then, the choroid then is incomplete at the optic nerve. There we go. So there we have the choroid coat for most of the back of the eye. Okay, so then anteriorly, meaning towards the front. Anteriorly, it, and I mean the vascular tunic here, then it projects inward. I'll show you what that means in a moment. To form the ciliary body. All right, so let's draw that in now. So it's going anteriorly. Remember, this is anterior in this direction here, just so you recall. So anteriorly then, it projects inward, in towards the center of the eye. Like this, there we are. And it has some projections, blood vessels coming off of it, like so. There we are. So now this and this, these then are the ciliary body. Still very vascular tissue. So there we have the ciliary body. This is still all a part of the vascular tunic of the eye. And then even more anteriorly, it, again meaning the vascular tunic, projects inward again then to form the iris. You've probably heard of the iris of the eye. So let's put that in. So now we have this going forward again, like so. So here's the vascular tunic heading in, or rather heading forward anteriorly, and then heading into the center. I'm going to move that back. No, that's all right. So there we are, like that. So this, and this, these now, that, and that, are the iris of the eye. You can see your iris. It's the colored portion of your eye there. It gets bigger and smaller depending upon the light levels in your eye, the light levels hitting your eye. Okay, so there we have it. So you have now the full vascular tunic, the choroid coat over most of the back, the ciliary body projecting inwards, and then the iris separately projecting inwards. And just so you know, the lens of the eye is actually, I'm just going to kind of make it a ghost here for the time being, but the lens of your eye is going to be roughly there. It hangs basically off of the ciliary body. So that's the lens. It's a lecture for another time, but just so you know what's going on. Okay, so there we have the rough structure. This is not correctly in proportion, but that's because I was trying to show you the various different parts of the vascular tunic. Okay, so what are these things anyway? So the ciliary body then, now that you see where these things are, what do they do? So the ciliary body then is thickened, blood-rich tissue around the lens, which I have drawn in for you there. Let's do this. And this contains the ciliary muscles then for controlling lens shape. So that then are these things here. So what I'm getting at is that here and here in the ciliary body, then there are muscles. And you know what muscles do? Muscles contract. It's the only thing they know how to do. So muscles, if you have this lens here, if the muscles contract, the lens is going to be pulled out and it's going to become flatter. If the muscles relax, then the lens will become more round. We will get to the shape of the lens and why that's important in the lecture on the lens. So anyway, here, as I said, in the ciliary body, then in addition to all of this vascular tissue, we also have muscles. Now you should be paying attention to the fact that we have this vascular tissue here. Why do we need vascular tissue there? Because everything needs blood. And so this is supplying blood then to all of the tissues of the different layers of the eye. It's also going to be providing oxygen to the important area here in the front. So as I said, here is the blood supply for all of the workings of the eye. So anyway, here in the ciliary body, you have those muscles that can contract and thereby control the shape of the lens. Still carrying on, however, about the ciliary body. So I'm continuing now with this. Continuing with the ciliary body, then, there are what are called ciliary processes. Ciliary processes of the ciliary body. You can kind of see them there, these little things that are kind of hanging off here. These are, let's do this. The ciliary processes then are basically folds in the tissue of the ciliary body, and the capillaries, the tiny blood vessels therein. The capillaries then secrete fluid into the anterior segment that's an S there, into the anterior segment of the eyeball. This becomes important, but basically the anterior segment, which is up here in front of the lens. I will give you a special lecture on the segments of the eyeball in a later lecture, but for the time being, you have the ciliary processes here that are secreting fluid into the anterior segment of the eyeball. So the anterior segment then is basically that which is in front of the lens. And then I'm going to do this. The posterior segment, just so you know, then is behind the lens, and the lens itself is held in place by the suspensory ligament. What I'm saying here is that you have then the ciliary body projecting inward here, and then, so this then is round, basically. You have the ciliary body going inwards all the way around, and then on the very interior of that circle between the ciliary body and the lens, you have this ligament that completely surrounds the lens, and that ligament then is what holds the lens in place. So now we've talked about the ciliary body. We'll talk about the iris. So this is a part of the eye you can actually see from the outside. It is visible, and this is the colored portion of the eye. So if someone has brown eyes, the reason that they are said to have brown eyes is because their iris is brown. And so this then is between, as I have drawn here, between the cornea and the lens. Remember, that's the cornea, the clear part of the fibrous tunic at the front, and there is the lens. So the iris is between the cornea and the lens. It is donut shaped. As you know, you've all seen the iris of somebody's eye. Here we are. It has those nice lines in it, like so. So here is somebody's iris. So the whole then is the pupil of the eye. So that there is the pupil, right there. And this is the opening that lets light into the eye. So here you have the pupil. That is that dark little hole at the front, and it is through that light passes. So here we have light. Light can be green. So the point is, here we have light going into the eye, and the light has to then get through the pupil there, and then through the lens to get to the rest of the eye, where that light can be detected by the sensory tunic, which is a different lecture. So there we have light going in through the pupil. That's the only place that the light can get through. So the iris then is made of circular and radial smooth muscle. What do I mean by circular and radial then? So circular is going to be like this. Circular muscles. And again, if you have an iris with a pupil, the radial muscles will be like that. So these then are the radial muscles. So why do we have muscles in the iris of the eye? So those iris muscles then, these control the size of the pupil. And I'll make that a comma. And therefore, the amount of light that gets into the eye. Basically, getting back to the pupil here, if the pupil is big, if those radial muscles contract and draw the iris so that the iris is narrower, that is going to enlarge the pupil, and that will let more light into the rest of the eye. And on the other hand, if some of those circular muscles contract, then you're going to wind up with a very small pupil there in the middle, and that will only allow a little light into the eye. You can watch this in action. You can see it yourself. Go into the bathroom, look in the mirror, look at the pupil of your eye. Now, turn the light out. Get yourself in front of the mirror, find a way, have a friend if necessary, have a friend turn on the bathroom light while you're looking in the mirror, and you can watch the size of your pupil contract. You can also do this with a flashlight, just by shining a flashlight in your eye, but one way or another, have some fun, watch your own pupil contract when you put bright light on it. The reason for that is that you only want basically the right amount of light onto your pupil, or onto your eye, onto your sensory tunic. So you just want the right amount of light, not too little, not too much. So as a result, if you have a large pupil because it's dark out, it's busy trying to let in as much light as possible. But on the other hand, when that light gets bright, you do not want to completely bleach out your sensory tunic, your retina. So at that point, the pupil will contract so that way you're letting in less of that really bright light. Then, as I said, if the light winds up becoming more faint again, the pupil will slowly enlarge to let in more light so that you can see. And that's basically how it works. And that's it for this lecture.